Alrighty guys, so today I'm going to be showing you the completed, now restored high voltage probe in its box. As you can see, it's been repainted and also re-stenciled. Put the stencil back on there, looking pretty cool. So this is now mahogany brown. As you can see in the previous video, this box was in quite a bit of a state. The actual ply, this box is made out of ply, the wood had delaminated on the outside, just the top layer, probably in a bit of damp or something like that. So I managed to peel the rest of it off, sand it down, and then obviously paint it in this nice new mahogany paint, which brings it quite well. You can see the nice wood through that, so that's looking pretty cool. And then obviously made up a stencil manually, which took ages to cut out all of the paper to make that, but yep, worth doing anyway. Came up pretty cool. And then painted the clasps and the hinges, sprayed those in black, and also around the back. There you go, 3 hinges around the back, so pretty cool. So we'll pop her open and let's have a look inside. Alright, so there she is, all spoiled now in the box. High voltage probe, looking pretty cool. So I did another modification to the probe actually in here the other day, and that was the cone, as you can see here. So as mentioned in the previous video, I was going to make an actual, like a tip to go on the end to make it a bit easier to actually use, because before it's hard to actually see where you're probing with that kind of end on it. So I've made a pointy one, which is pretty cool. That just slides on there and you do it with the grub screw and that clamps it on. Doesn't have to be super duper, so it just literally goes on there. So that's pretty cool. So let's take it out and give it a test run, I reckon. So try and do this one-handed. Take it out. Alrighty, out she comes. All still in immaculate condition. 1970, last tested. Might be out of calibration now possibly, but we'll see about that. So yeah, there's the tip, and that will go on the end of there, just like that, and then just nip that up there, and that holds on there nicely then. So you've got a nice brass tip, and it's also much better that way, because it means if I end up burning the tip on something, say it got hot, or say I'm measuring on some bit of power now, and for whatever reason it melts the tip a little bit, at least it's a part that I can actually machine up and make a new one pretty simply. So yeah, so that's pretty cool. The other part of the probe, there's the another red stick in there that actually goes on the end of the stick and enables you to measure the in between the power lines without touching the other. So I guess that enables you to do that, as it shows in the drawing. It actually comes with a drawing. It's quite cool. Open this up. Just looking at this drawing gave me the idea for the tip, because that's the red probe in there, the extension, the bendy bar. It's not actually that bendy, it's quite rigid, especially the end bit. But yeah, that slides over the end of there and enables you to do that. But this has a different kind of connection for the tip. It has a screw that goes through on it, and a grub screw as well. So I kind of went with that idea. As you can see, it's there. That's the connection there they're talking about. So they've got a screw that goes all the way through to the one side, and then there's a grub screw on there, but I don't want to worry about that too much, having to do that 2 screws all the time every time I take it out, because it doesn't actually fit in the box without having to take it off. So I just want to make it a little bit more simpler and just go with the one grub screw. But I might change it if I want to in the future, make a new one at some point. It doesn't take long to knock one of those out. So yeah, that's pretty cool. Just get it back in there, it slides into its, no, not that way around, hold on. It all has its own little place in this box, as you can see. Okay, beautiful. Yeah, so it wouldn't really take me too much longer if I wanted to make another one at some point, or if this one starts looking a little bit worn out, I can knock one up on the lathe. I've got over here, just find a bit of brass scrap and literally just knock one up on the bantam there. So yeah, it takes about half an hour probably the second time around. This first time took a little bit longer trying to find the bits and pieces to do it with, but I know where I'm going from now, so yeah, that'd be pretty cool. So if I needed to make a new one, I could always do that, so not a problem. Also to drill the hole for the grub screw. It's all good to go. So that's quite cool if I need to do that again. Okay, so I think we'll give it a test run. Anyway, I'll put this drawing away. Oh, something interesting about the drawing before I do put it away is the date of the drawing. It's 1957. So pretty old stuff there. Pretty cool. Manchester. Yeah, that's when things are actually made properly. Right, I'll stick that back in where it came from. That was it there. And we'll test the probe. So we'll get the probe tester out. That's quite heavy. So we're going to be using an external battery today, as you can see, just over there. So if we connect this up, so for the external battery I need to connect to A and B, which is these guys here. So take those off because I know these crocodiles don't quite fit in there. This is meant for like a, ooh, trying to get away, stay. These are meant for like a wired connection, I guess. You just twist it around and just clamp them in there. So let's call B as negative. Let's clamp that on. There we go. And the other one. I'm going to move the camera around a bit. This is a bit of a three-handed job, this. Alright, there we go. So we'll just connect that onto the negative of the battery. 6-volt battery. And then, I'm sorry, this is one of those stupid APC ones. This is a 12-volt battery, sorry. It's a funny size thing. So yeah, there's the positive. So that is now ready to go. If I get the probe, connect the earth onto it. There's a nice big clamp. Yeah, that's quite reliable. That's a bit more easier to use another little clamp. So yeah, LPS, made in England, quite cool. So that clamps onto there. Earth clip, and then the probe goes in there. So if I take the probe now, wield the probe. I have to come up with a name for this probe. I was thinking about it the other day. I was thinking possibly along the lines of Excalibur, but I don't know. It's a bit too like cliche, isn't it? You know, maybe we could call it Hexcalibur if it goes wrong all the time. I don't know. We'll see. I'll have to come up with something. Right, so aim the probe down onto there, and then you'll see when I push down. Not sure if you can hear that. That's testing. That's on the 5-volt scale, which is the bottom scale the way we were looking. So that's about just around 4 kV there, which is what it's designed to output on here. 3.5 to 4 kV terminal voltage. So yeah, that seems to be working pretty cool. Pretty fine. So yeah, I'll disconnect that. Those 3-hand jobs. Right. So now we can take the probe and use it on something a bit more realistic for what I'm going to be using it for. So we've got this center tap MOT stack at the moment, so that's going to be running that at plus and minus 2 kV. So we're going to get 4 kV on the spark gap there, but I'll only be able to measure it reference to ground. So I should get about, I don't know, 2 kV out of there, which we can prove with the we can cross-reference it with the other probe, which is displaying just over there. So if I just find a nice reliable earth to stick my earth lamp onto, such as that one there. So I know for definite I made sure that earth was very, very good inside of that stainless steel box on the line filter there. So yeah, that's pretty cool. So we've got our earth connection now attached to the probe. And that should just be long enough to measure over to here. Yeah, there's loads of slack. It's actually a loop there, but it's not too much of a problem. Right, so let's turn this on. So this is a dual MET center tapped plus and minus 2 kV AC, and there's the what we got here. We got the input volts. So that's 0 to 230 coming from the variac there. I'll probably have it up to 240 to run it because that's what these actually ask for, 240. So we'll run them at that. Limited to 1000 watts. I've got 1000 watts linear halogen in a E40 style type package, which is quite handy, quite neat and easy to store. So we've also got amps, AC amps there, so you can monitor the amps going into the circuit just for the reference. And safe gap closed, so danger. Yeah. Alright, so we'll turn the variac on, 0 volts, switch on, and then take up the voltage 240. 240, yeah, pretty cool. So the other probe's saying about 1.9 kV over there. You can hear them humming away, and there's the ballast, resistive ballast there at 1.8, 1.7 amps. Pretty cool. So that seems to be running nicely. Right, so I'll take my probe now and measure it on one of the stands on the spark gap there. Get about there. We should see a nice reading similar to what we've got over there. So saying just over 2 kV on the 5 kV scale there. So yeah, that's pretty close. It's a little bit higher than what that's saying over there at 1.9. Over there, 1.9. About 2 here. So it's pretty close. Call that 2.1 if you want. So let's try the other side anyway, because this might not be quite even. So we might get a problem there. So let's measure the same side that the other probe's measuring. On that side. An imbalance, and it looks like it. Yeah, there is. So it's ever so slightly lower on the one side, which is interesting. Which actually looks like 1.9 there, which is actually what that's displaying over there. So that's slipped off. There we go. So that's actually pretty accurate. That's quite impressive. So what if we take this up to 2? Can we get it around 2? Come on, 2. That's going up in years. There we go. 2001. Oh, it's a time machine. Look, going back in time. Some better years there. Oh, let's go. It's going around a bit. So yeah, about 2 kV there. Right, so 2 amps in. And I'll measure back on the spark gap. Wait for it to stabilize a bit. There we go, he's about 2 now. He's just about making it onto 2. So yeah, it's probably a little bit lower than what it needs to be. Mind saying that, that's crept back down. Now the line voltage is changing ever so slightly. So that's pretty cool. So let's measure the other side again, see if it's high still even at this voltage. Yeah, just just under. So these do vary a little bit. My spark gap rotated around a bit. Never mind. I'll rotate that back afterwards. Got little O-rings under there to adjust those. Makes it a little bit more easier to use, so that's quite cool. So, all in all, pretty accurate. Mind that might not be accurate, this one here. Don't really know, but pretty accurate, this one. So that's quite cool. I also can tweak it there if I need to. Have a go at that. But yeah, pretty cool. That's running nicely. And that end tip's quite handy. Nice to use. Awesome. I'll just switch this off, make it safe a second. No point running it when we don't need it. So accidents happened. Alright, so switch it off, open the safe gap. Nice and safe now. Right, so pretty cool. Ah, yeah, you'll also notice the workbench top has now changed into this new I think it's block beech, but it's actually the chipboard style one. It's laminated chipboard, so it's pretty cool. It's quite handy for out here. It actually looks nice to work on. Really makes it, except for I can't scratch anything now, so I'm putting the heavy stuff up on bits of wood so I don't scratch it. And these things are mainly all got feet to them. Everything else, rubber feet. Even the box has rubber feet over there. You can just about see it. So yeah, pretty cool. And also the floor has changed as well. We've managed to paint the floor in here. As you can see, got the vice apart at the moment. That's just been shot blasted for spraying. I'll just put this down a second. You can even put things, you can nearly eat off the straw, except for now that we've got it dirty again. You could have nearly eaten off the straw about a week or so ago, but never mind, things get dirty. So yeah, there's the vice. That's just been shot blasted today, and that's just been primed about an hour ago. So that's dried pretty quickly, as it is with primer really, and then that's going to be coated tomorrow in a similar colour to what the milling machine is here. I'm not sure what you call that. I know what the tin is actually. What is it? Wild Thyme. That's a bit of a weird shade of grey, but yeah, pretty cool. So that will look pretty interesting for the vice anyway. A couple more ballasting lamps I got there. What is that? That's a 200. Got a 25, 15, and then I happen to have a what is that? Halide, a 100-watt halide there, which is quite handy. It's also got the UV shield in there. You can see the UV shield, which is quite handy to keep hold of if you're doing any spark gap type stuff. And a UV shield for it. That's where to get them from. An igniter, power factor cap. So yeah, that's quite a cool unit. It actually looks like it would go on the wall in a really weird sort of what kind of style you call that? It looks like a wall fitting, doesn't it? Put it up on the wall. Nah, I'm joking. Nah, that'd be pretty rough. It doesn't really meet the regulations for installing stuff, and I don't know how I actually terminated that, but that's also a bit rough. I got the colours right this time anyway. Just about. Yeah. Anyway, I'll put that down. No more distractions. Not too many anyway. Yeah, they're quite handy. I might get a few more of those for ballasts. They're a little bit more compact. My 750 is about 4 times the size of that, and it's a mega thing to be transporting around. And if I break it, it's also vintage, so I don't really want to do that. So I've transferred over to these linear halogens here for my ballasting, which is quite cool because the light allows you to actually see what's going on with the circuit, rather than it just being something in a box or something in water somewhere. You can't actually tell what's really going on until you start hearing bubbling or something like that. So yeah, that's quite handy to have. Get a few more of those. Just unhook the probe. Put it back in this box. There he is. So yeah, pretty happy with the probe now. I think that's pretty much how I want it to be. The usage, general purpose really. It's my new chicken stick plus measuring probe, all in the same device. It's meant for what it says on the tin really. It's a high voltage probe for measuring power lines. Ex-MEB, which is the Midlands electricity board over here in the West Midlands. They're long gone really. They've been replaced by the Western Power Distribution now, but you know, you still get some of their old bits and pieces you see around. Not quite cool. Wouldn't mind the Ex-MEB pole pig, but trying to get hold of one of those kind of things is a little bit harder than. Well, this is pretty difficult. I was lucky I came across this in that flea market just before Christmas last year. It was actually. So yeah, 50 quid. Not bad for 100% complete. Minus the handle, actually saying 100%. I need to find a handle. You can see where the old handle went. I've actually got a drawing, a picture of this unit one of these units, Model 1s, and it's got a picture of the handle on there, so I might make up a handle which just slots in there, hinges down, goes along like a tube and then goes back up. So it actually hinges, so it'll fall down on there when I've got it, when I'm not using it to carry. And it'll look nice as it is. So yeah, that's probably the very last thing to do to it really. But otherwise it's looking pretty cool. There's the phasing meter there. I need another probe to actually use that to phase in between two phases, say 11 kV, L1 to L2 or whatever combination you want. But John's got another one of these, so I plan on taking this with me when I go to see John. So we'll actually have a go at phasing something, so I can actually measure from one side directly to the other. That is off. I am going to rotate that back. Squeak. There we go. Perfect. So yeah, so we'll actually have a go at actually measuring from one side to the other using this device and another probe at some point, but that'll be a future video. But yeah, pop that back in there. So that little lever over to hold it in, and I'm carrying it in the MEB van, which I don't actually have, but it'd be cool to have one. But you know, I think those are long gone as well. So yeah, pretty cool. So I'm pretty sure that's everything I wanted to cover today. Hope you've all enjoyed the project and everything. It's been quite a cool little project restoring that, and it's going to be pretty handy. You should see it in most of my up and coming videos where I'm measuring stuff which is a little bit more high power than flyback. Otherwise I will be just using this for measuring flybacks, because that can measure up to 40 kV DC, which is quite handy. But obviously for this kind of stuff you want really not to be using that. I've used that as a reference today, but you want something a little bit more beefier, you know, something that's designed for the power, kind of power that these things put out. So yeah, a new chicken stick probe.